Good afternoon, Professor Noble. It is such an honor to have you here today. My name is Meiln Song, and I am currently a student at Crofton House School in Vancouver, Canada. I've been very inspired by your decades of work and influence in systems biology, as well as your advocacy for a new synthesis in biology. For the benefit of the audience, could you give a brief introduction about yourself?
I'm called Denis Noble. I've been a professor here at Oxford University for, well, now something like 62 years. And before that, I studied at University College in London, where I was responsible for creating the first mathematical simulations of how the heart generates its rhythmic activity. And for about 40 years after that, I carried on, first at University College London and then here in Oxford. That's the story over the whole 65 years.
Thank you. And your work sits at the intersection of science, society, and technology. So as an aspiring entrepreneur in biotechnology myself, I'm very curious to hear perspective on topics surrounding AI and some current challenges scientists might face. Your early heart models changed how we understand biological systems.
That's right.
Yeah. But now AI is pushing stimulations to a whole nother level, like predicting protein structures and analyzing genomic data.
Those are very clever ways in which we can use AI. Totally agree. And where AI can do things faster and better than we can, we should certainly use it. Where does it not work? Well, ask ChatGPT or any other system you like. What is it that Denis Noble is going to do next? It will be able to find some ideas from what I've published, but it won't know the answer. Why? I don't even know the answer myself yet. All AI depends on computation run on crystalline silicon. The difference is fundamental. So what that means is that biology, a living organism, can access an immense variety of developments within the chance events of what water enables to happen. Because in water, the molecules can diffuse everywhere. And they have to because they're knocked around by the water molecules. It's called Brownian motion. It was discovered almost 200 years ago. And it's all to do with the buffeting by the water molecules. There's nothing like that in a silicon chip. Now, people say, well, that's all right. You can introduce stochastic equations into the programming of the machine, and that will give you openness and variety in what the machine will do, because you cannot predict in advance which pathway it might take. But that's not the same as using the chance to create a purposive direction in which to go. I think in relation to predicting protein structure, for example, there's many things we can ask AI to do that will actually help us, and we should use it to do that. But even there's a big problem. 70% of proteins are not completely determined in their three-dimensional structure. It all depends upon the context in which the protein finds itself. You can have a protein which in one context, in the watery environment of the living cell, can be an enzyme. It can be, just to be technical for a moment, what's called an aconitase. It just makes a particular process happen more. It's an enzyme. It's a catalyst. It makes it go faster. But if you find it in a membrane, it acts as a channel that allows iron to enter red cells. It's two completely different functions. No, not impossible, because these proteins are very long. They've got many domains. One can act as the channel-making part of the protein, the other as an enzyme acting catalyst part of the protein. It's perfectly possible for that. Well, in the case of the aconitase enzyme, it does just that. So given that about 70% of proteins are flexible like that, dependent entirely on the context, which is the living cell as a whole, again determines which pathway those proteins go through and how they develop and how they function. So yes, we can predict with AI more quickly and possibly more reliably some of the structures that an enzyme like a protein is capable of forming. But the difficulty lies in the fact that it's open-ended. We're back to that difficulty that there's stochasticity there. So even in predicting protein structure and therefore protein function, we can get tremendous help from AI, but it will have great difficulty working out how to deal with all of that stochasticity. It's to add not only stochasticity, chance events, to their algorithms, their mathematics, but also the way in which that is used purposefully in order to create what it is that will help the organism, in this case, the AI system. That's what I think the challenge is.
So, and Professor Noble, up until recently, computers and machines, they handled repeated modeling tasks. But now AI, it is replacing the need for repeated ideas themselves. So how does this shift concern you about the future role of health professionals and scientists?
I think we're going to, as scientists and as doctors, we're going to have to adjust to the fact that we can use AI. But that means we're going to have to know what is the best way to use it. What are the problems that are naturally a problem that AI can solve very quickly? If I want to know, for example, all the references to one of my articles so that I can start to write a review on how that's developed since the article was published, maybe 20 years ago. So I can then review the progress in the field. If I ask Google Scholar, which is in effect another search engine, it will produce all of those articles for me, list them year by year. I can access them very quickly. Using that, it makes a huge difference to searching otherwise through what might it be? Literally billions of possibilities. So AI is extremely good at that kind of thing. And in effect, Google Scholar is a form of AI, focused on a particular person and his or her publications, and you can access all of that extremely quickly. That's what we've got to get used to. What is it going to be very good at, and then use it to do that.
But do you think there will ever be a time where these technologies will be posed as a threat to their profession?
To replace a professional? To some degree, yes. I can't see what would prevent us using AI to guide an operation, for example. But it would be a little bit like getting a driverless car, wouldn't it? It's probably best to also have a driver sitting there waiting to take over on those rare occasions when it needs to, because unfortunately those rare occasions can be very infrequent, but they're disastrous if you don't know how to handle them. I'm not saying that AI could never replace all of that as an automated, self-driven bicycling or vehicle, but it's difficult. And I think we're wise to take this step by step. Those who've already experienced having driverless cars on their roads know what the problem is. So my feeling is that with AI, there'll always be a sort of boundary where we have to supervise what it's doing in order to come in on those rare events when it can't really work it out properly. That's my view of it, but it's a personal